This is going to cover essentially Hashcat. If you use other password cracking tools, just be aware, use Hashcat. I'll reinforce that as we go throughout the presentation. So quick start. If you're doing password cracking and you have a hash, just go to crackstation.net and copy and paste the hashes. It's going to be one of the quickest way to get the password information from non-salted hashes. There's a variety of password cracking tools. Hashcat, John the Ripper, Kane, Hydra. There's more than that. Hashcat is one of the fastest, most efficient tools that you can use. That's why it's highly recommended. So some basics behind password cracking. What do you need to know? So a hash is a one-way encryption of a password. Rainbow tables are pre-computed hashes. So you have normal text, you encrypt it somehow into a hash, and then you have to compare whatever somebody enters in as a password, it has to be hashed, and then you compare the two hashes. Rainbow tables is just, instead of trying word lists, you've pre-computed all of the password hashes so you can make faster comparisons. It speeds things up. And then assault. So assault is extra info that's added to somebody's input to obscure what's in the hash. It makes things a little bit harder. So you can't just use a plain dictionary attack in order to crack passwords. Okay, so 3 basic attack types. When you're trying to crack passwords, you got brute force. It's attempting all possibilities one by one. So for example, you try A, then you try AA, then you try AB, then you try AC, etc. Dictionary attack, it's what it sounds like. You have a giant list of words or phrases or numbers or symbols, and you compare the hash values of those words to the hash that you're trying to crack. And then finally, you have hybrid attacks. So hybrid attack uses a dictionary and checks variants of that list. So you can find lists in Kali Linux in the users share word lists directory. That's going to be important for NCL. You can generate a word list based on some parameters, and it's highly recommended. Make your own word lists. You can also find a bunch online. Normally for NCL, the ones pre-built into Kali are sufficient for most of the passwords, maybe not all. Here's some examples of what a hash looks like. And these came straight from the Hashcat website. You got MD5, you got MD5 with salt. The salt could be added before or after the actual password hash. This part here with the colon and then the number indicates this is the value of the salt. This is the value of the actual hash. Don't assume it's going to be like that when you find the passwords. We'll get into formats a little bit later. It's highly recommended that you use some Google to look up what the fields or field separators mean, and we'll get to that. It's like here we have $PDF $. Okay, how do you figure out a hash type? Basically, you guess. I'm not joking. There are some things that help, like length of the hash, but it's a good idea to use some software. So you can use hash ID and then hash that you want to identify. If you use the -M option, it'll show you Hashcat modes, -J for John the Ripper. It's not always correct. There's another hash identification tool called Hashtag. You can download it on GitHub, or you can just Google a bunch of websites that provide kind of hash detection functions. Those are also highly recommended because they're easy to access. Where do you get password files to crack? So it depends. Search online. It depends on the application, operating system. You'll find hashes in password files, data structures, error checking in various protocols, in apps where the developer thought they were sneaky and they would make it secure by using a hash, and various encryption related stuff. On Windows, in order to get the hashes for Windows users' passwords, you need to extract it from the registry. So you can do that with these commands: reg save hklm/sam, and then the location you want to save the Hive file to. Once you extract the registry files, this will require administrative permissions. You then want to download Mimikataz. It's one of the better programs you can use to extract password files. Mimikataz, or cats, Mimikatz. I'm going to call it Mimikatz. It looks like this. It's available in both Linux and Windows. So you type Mimikatz into the PowerShell or command prompt. If you want to log the stuff that you're doing, the command is log mimikatz.log. It'll save it to the directory that Mimikatz is in. The command in order to extract the Windows account information is lsa dump ::sam /system:/system.hive/sam:/system.hive hiv. The system.hive and sam.hive are going to be whatever you've named them once you've extracted them from the registry. The results will look something like this. There will be an RID. It'll indicate the username, user1, and then a hash in the NTLM format, which is right here. Where can you find passwords on Linux? You can find them in the /etc/shadow file. This is an example here. So we see our friendly Fred username, and then this long hash here. The $6 is actually tells you what type of hash type it is. In this case, it's SHA-512. There are others. So $1, MD5, et cetera, et cetera. You can look that up online if you come across something that you don't recognize. There's a variety of fields. They're not super relevant to password cracking, so take a look at this if you're interested later. On Apple and Mac, you can find the password hashes in the var, db, shadow, hash, and then the GUID file. I don't have a Mac personally, so you can look into that later if you have one. And there are also hashes you might be interested in iOS, Android, Cisco iOS, etc. Use a search engine. You can find out where they're located. Some of them are harder to extract from than others, like Windows has made it a bit more difficult. Okay, moving on to how to use Hashcat. This is what Hashcat looks like when you type it in on the command line. So you type in the command name and then -m and a number, which is for the encryption type. So that's the hash type that you're trying to break. The -a and then a number will indicate what type of attack. -o is where you want to output the results, which I recommend. And then you give it a word list that you want to use, and then the location of where the hashes are stored. I think I may have actually flipped that around, rocky.txt. I've flipped around the last two, so double check the syntax when you run the command. Here's the encryption types or hash types. These are the ones that I think you're more likely to run into in some competitions. MD5, SHA. Keep in mind that there's a pass.salt and a salt.pass for many of these, and you may have to try both variants in order to crack the hash. Okay, types of attack. Hashcat supports, I believe, 5 types of attack currently. The association attack is new, so don't ask me about that one. You have a plain dictionary attack, which is indicated by -A0. You have a combinator attack, which takes 2 dictionaries and makes combinations of those dictionaries. There's a brute force attack and mask attack. Mask is pretty cool because you can tell Hashcat the format and it generates the password format to try and crack. If the password you're trying to crack is less than 27 characters, you can use the -O option and it'll speed things up. That's important in a competition. Okay, let's go to dictionary attack. This is a dictionary attack and we're actually going to use some rules with it. The example is up here. You have hashes.txt, password list.txt, -r rules / dead1.rule. Hashcat comes with some of its own rules in the user share hashcat /rules directory. You can use those. Anything other than a plain dictionary, you will probably want to use some form of rules for. I recommend the Hobo 064 rule set. The reason I recommend that particular rule set is because when you're going for efficiency versus the success rate of passwords cracked, it is a highly efficient rule set. If you have a powerful machine, go for it. You can use the dive rule set or something similar to that. You can find rules online. There's a quick write-up in the slides here if you want to look more into that. Combinator attack. The combinator attack, it's a pretty simple concept. You have a dictionary 1 and a dictionary 2, and then it will go through variations of that dictionary. You can use the -J and -K to specify which side to append to what. So for example, if you were trying to crack a hash that you think is in the same format as the competition's flags, which they almost always do at some point, the first dictionary, you could have sky and then variations of the first 4 letters. And then in the second dictionary, you could just generate a static dash and then variations of numbers that you need. Highly recommended that you do that before the actual competition if you want. The next type of attack is a mask attack. So it's indicated by the -A3 option in Hashcat. You have hash, and then you can indicate either a file, it's a .hc mask file, or you can type out the mask itself in the command line. It may be a good idea to make the masks ahead of time once again, and then just go ahead and run your mask file. Masks test all combinations from a given key space. It's kind of like a brute force attack, but it's curated to specifics that you think you're going to find. So if you find password requirements from an organization that auto-generates passwords for people, a mask attack may be more efficient. Not maybe, it will be more efficient than a just standard brute force attack always. If they can't have a password less than 6 characters, and you know it has to have like a capital at the beginning or the end, or they use a username, you'd use a mask attack. This will also be very good for trying to crack flag hashes. So highly recommended you learn a little bit more about this. As a quick example here, you have the -A, and a simple mask example is this. It says password $D. Password is static. Every single thing that it tries will have that password, and then it will generate a character from the $D. So if you look in the built-in char sets, $D will be a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. You can get a little bit more complicated. Read the wiki to make sure that I'm saying everything correctly here. But you can create your own character set. So -1 $L $U means anytime you put a $1, for example, right here, what it will do is it will generate a character from the character set you created. So the character set $L $U is options. It's either lowercase alphabetic or uppercase alphabetic letter. Then you see this space. So after this space, this is the key space that's going to be generated. So it generates a 1, and then a lowercase letter, a series of lowercase letters. Every time you see a $L, it's a lowercase letter. You have a static 19. So they know there's a 19 in the password, a D, which is a number. And an example of the key space that's generated are these A's and then a 1900, or these Z's and a 1999. This is the format of the NCL keys. There may be an NCL instead of Sky. Most of them will probably be Sky. Here's an example mask that you may be able to use. If you understand how masks work, there's actually an inefficiency in this mask, and the challenge for you is to figure out how to fix it so that it goes faster. Here's some examples you can try out. These came from Crypto Kate's blog. You have example hashes in the Sky ABC number format, and then you have some Pokemon over here. So knowing it's Pokemon should help with the dictionary you choose. Give it a try. If you can break both of these, you'll be good for most the password cracks. I need to talk about base 64 encoding really quick. It's not really hashing. It transforms letters or numbers into a type of encoding, in this case, base 64. And oftentimes they'll use that to obscure results. So you may run into this in web application exploitation, where a developer will try and hide like a cookie number by base 64 encoding it. You can also run into hashes that are base 64 encoded that you have to decode and then try and crack. So some of the more difficult exercises, they're going to get a little bit tricky. And sometimes they will chain various different encoding types together to make things more complicated. This technique is also used in the cryptography sections. Remember to change your passwords. Hashes get dumped to the internet at all times. You can click on these links if you're curious to see, and here's some references.